Students, in this particular program, we will learn how to evaluate square roots. Now, in physics, square root is a very important component, and most of the questions will involve square root. Say, for example, let us take an expression of this fashion. Say t is equal to 2 times pi multiplied with root of L over g. So this is a popular expression or a formula in physics. Now I would like to use this formula and obtain the result. Now this is just an illustration, so the data that I feed in might vary. So do not relate this to the actual physics that is observed when an experiment takes place. So having mentioned that, I would like to go on to demonstrate how exactly we can find the square root in C language, or I should say C++ language. So first let me just start off by including IO stream. Now to activate the square root libraries, we would have to use include math.H. If we do not include this, we would not be able to utilize the square root libraries, or in other words, the libraries that are actually giving us the facilities to evaluate square roots. So that's the meaning I wish to convey. So having mentioned this, let me just go on to include the namespace std, and then the parent function int main. And now I would like to get in the variables. So I will declare float of length. This is a variable, and then g and pi. Right. So all of these values are declared, and t, time is also declared there. So p, that's pi, the pi comma time, and that's fine. So as I mentioned to you, I would like to evaluate root of L over g. Right. So I will ask the user, please enter the length. Right. The user is going to give me the length, and I will receive the length using cin. The length is received, and cout, please enter g. In fact, I could have taken it as a constant. Okay, so let it be like that. And then cin, this is also obtained. So g in this case. So we need to calculate 2 pi times. So time is equal to, pi is a constant. So if you want, you can also get the value of pi. Please enter the value for pi, because sometimes in physics they would use the value of pi as 3.14. Sometimes they may go beyond that, depend upon the specifications. So I will get the value of pi from the user. So time is equal to pi times, now this is where the square root function comes in handy, sqrt, that is the square root of, now we need to divide length, L-E-N-G-T-H, length divided by g. That's fine. So that is going to be the output. So output is going to be the result is, or instead of saying result, I will just say t. T is equal to I will give a space there, one tab space, and then I will publish the result. That's fine. So I'll return the value, return 0, and then I'll close the parenthesis. So as I mentioned to you, I have just included, or I've just utilized this formula, t is equal to 2 times pi. Okay, so I need a 2 there, so I will place 2 into pi times sqrt. So that's fine. So I'm saving it. So I'll give a length and the gravity. So please enter the length, say 20. It doesn't matter, the unit is not specified here. So this is the value we have got, 8.9743. So if you want, you can use a calculator to find that out. So let me just go and get a calculator. 20 by 9.8. Okay, I get this. Then I would take the square root of this. So if I were to take the square root of this is what I get. Then I will multiply it with 3.14. Then I will have to multiply it with 2. So what do I get? You see that 8.97142. So that's rounded to 8.97143. Of course, we can extend the specification, depends upon the value of pi we have got, and we can handle that in C++. So this is just to show you that our execution and our implementation of square root is absolutely correct. So students, I think this is a good place for us to stop. We will